Yo, what's up guys? I'm back. I'm going to be brief with this intro. I'm making yet another engine, but this time, I'm going to combine all my old engines together. So basically, this is what I've been up to. I got a book about graphics programming. It's called Mastering Graphics Programming with Vulkan. This book is truly amazing. It of course has graphics programming source code, but it even has source code to show you how to support a good graphics renderer. It really hits the ground running with graphics. It assumes you've been working with Vulkan, and tries to elevate your Vulkan knowledge to the next level. I'll provide links below to everything I've been using in the description. Instead of just importing the project from GitHub, which comes with the book, I typed it up by hand without copying and pasting anything, which meant, inevitably, I created a lot of bugs, which I needed to fix. I think I've spent over 2 months typing up all the code and fixing mistakes. It's really top stuff. Shout out to Marco and Gabriel for how solid it is. Why did I do this? I feel it's pretty cringe to copy and paste someone else's code and call it your own. So my goal over time is to modify, remove, add, and refactor stuff until it becomes truly my own work. I just need more time. Anyway, what have we got here? I have loaded one GLTF model. It's JSON, and parsing JSON in C++ is great. There's a library out there that everyone uses, and I'm using it. GLTF models support physics-based rendering by default. Since I've loaded a GLTF model, I have a lot more data to go through. So now I'm handling all the materials that come with modern models, bitmaps, textures, and everything else an artist could throw at me. I'm not messing around this time. I'm sick of making tiny games because I haven't built up a good foundation, or all because I'm working with an older, outdated model format. We're going all in this time. I have a straightforward implementation of a physics-based renderer, using the bidirectional reflectance distribution function, or BRDF. The BRDF tells us how reflective or rough a surface is, so when we use the BRDF, things like wood and metal look very different from each other. The more metallic a surface is, the more reflective and refractive light we have to simulate. We do this with thermal reflectance, all to achieve realistic specular light. Within that calculation, we still need to simulate the angular light directions for simulating sub-surface scattering of light for the diffuse part. I'm just using the slick approximation for that. I'm setting the dielectrics value to 0.4 because I don't really see the need to render diamonds or anything else that's that shiny. And that's what other people seem to do. So I'm just going to do that. The next thing we need to calculate with BRDF is the geometry of the surface. If light hit a piece of geometry before hitting the camera, we discount this. So this means when we move the camera, different parts of the surface light up. The rest of the BRDF are just vector dot products that are just reprojecting functions. Altogether, this gives us the reflective equation, which is used to give us a weighted average of how the light is scattered for each pixel. So what does this all mean? So if I move up to this cloth, the shiny gold part is more reflective than the cloth part. I'm still learning all this, so I'll provide an excellent talk in the description below that likely explains all this better. This is all shader code. All this is in the fragment shader, and it's about 100 lines. It's all well understood, and pretty standard at this point. This wasn't the hard part of the process. The hard part was getting Vulkan to work with all the data coming in from the parsed GLTF, and getting Vulkan to take that data to the shaders. This time, instead of doing the bare minimum, I've really tried to focus on the Vulkan implementation. I've finally used the Vulkan memory allocator, or the VMA library. So now we aren't limited by buffer count. We also have the ability to run compute shaders, so 3D animation is now possible. I am deleting and allocating things on the CPU side in a way that's more appropriate for a game engine. I'm using a memory pool and a library that pulls the memory from that memory pool. The library is called TLSF, which is an older project that allows 2-level segmentation fit allocations. This is one of the benefits I found reading this book and going through the source code very carefully. I managed to find a good implementation of how memory is used in a game engine context. It's not as straightforward as you would think. Using things like smart pointers, with resource acquisition is initialization, destructors and constructors, all making it more convenient to allocate and initialize memory. When speed is paramount, and you're allocating memory in a fraction of a 60th of a second many times, this may not be good enough. So having tight control over your memory allocation is really important, and actually seeing how to do this is great. All that being said, my Vulkan implementation isn't ready. I still need to do things like make it multi-threaded to speed it up, and work around people's hardware. I'm also not sure if I've handled descriptor sets and layouts in an appropriate way that scale. I've written 4 Vulkan renderers at this point, and this is by far the most complex, and I'm only on chapter 1 of the book. So with further research outside the book, and using the book, I will make a better renderer that can do more impressive things. I'm also using ImGui to report back frame data in this lovely graph, which is all using Vulkan as a backend. I've just got to say, I love ImGui. I'm really not happy where things are right now. I'm aware how much progress I need to make, and my engine is way too similar to one in the book. Even with the refactoring, we are missing key sub-features like physics, sound, UI. I haven't yet integrated my physics engine into the game, so there really isn't any gameplay. I'm also missing transparency, and for some reason when you refocus the window after 50 minutes, it crashes. It's all not good enough. That being said, I'm truly sending it this time. I'm not worrying if I'll make it, if people will play my game in the future, if it's good or bad, how long it will take, if I'm going to work hard enough in the future. Maybe I'll get stuck on a bug and never get past it. Don't care. I'm just going to send it, boys. I'm even risking money. Every time I fail to hit a deadline, I give my mate £50, which includes making this video. I don't care if I go broke doing it, I'm going to do it. Thanks for watching. See ya.